Hey, good morning. Welcome to another week. Hopefully you are able to see what your quiz grade was and just make sure you're double checking and following along with what your grades are. As we move through the 9 weeks, we are going to kind of skip ahead and move to section 11.6. This is kind of an important part, especially to kind of help with geometry and some things you're going to see next year. But we are going to jump over chapter 10 and we are going to jump all the way to 11.6. We are going to work with, as it says here, radical expressions, simplifying those. First thing though, identify the perfect square. This is not part of your guided notes. You have, if you go to the section here in the modules, you have a guided notes. Go ahead and print those off. Fill those in as we're working here. The homework will be a worksheet. I'll show you that here in a little bit as we work through here. All right, identify the perfect square in each set. This is not part of your guided notes, so just pay attention here. Out of these, 45, 81, 27, and 111, 81 is the perfect square. How about 156, 99, 8, and 25? 25 is your perfect square. And the third one, we got 256, 84, 12, and 1,000. Now, this one's not quite as easy. This one's 256. And there's one more, the last one. 35, 216, 196, and 72. This one is 196. Well, what's a perfect square? It's a number that's created when you square a constant. Some of the basic perfect squares are 1, 4, 9, 16, 25, 36, 49. 25 is 5 squared. 81 is 9 squared. 256, though, you might not be as familiar with that one. That is 16 squared. Whoops, it's going to give me an error message. And that is 256. And what about 196? That will be 14 squared is 196. All right, so those are your perfect squares out of those numbers. And that's going to come up here in a second in simplifying radicals. Well, going through here, an expression that contains a radical sign. Now, there could be a square root or cube root. Basically, we are just going to deal with square roots. A cube root has a little 3 right up in here. We are not worried about that just yet. We're just going to worry about square roots. There are many different types of radical expressions. But in this course, we're only going to study square roots, like I said. Now, here's some cases of radical expressions. You got the square root of 14. We got the square root of L squared plus W squared. Square root of 2G times D. Square root of D over 4. 5. And some people might say radical 2 or radical 18. The expression under a radical sign is called the radicand. And so in this case here, the radicand is 14. The radicand here is D. The radicand here is 2. It's whatever's underneath the radical. Now your radicand contain numbers, variables, or both. So like right here, 2GD, that would be our radicand. L squared plus W squared, that would be our radicand. Just kind of a little bit of terminology there. Okay, recall that the square root of 16 equals 4 because 4 squared equals 16. 16 is an example of a perfect square. The nice thing about a perfect square is the square root of a perfect square is a whole number. These are ones you're pretty familiar with. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. And so on. Now, some ones you may not be as familiar with are when we get a little bit further up in the numbers. So if you think about this, the square root of what is 11? Okay, and you may not know that off the top of your head, but that is 121. Square root of what is 12? That's 144. Well, how do you figure out that number if you don't know it? Kind of go backwards. So if I want to know the square root of what number is 13, I go to my calculator and hit 13 squared, and that's 169. So the square root of 169 is kind of, we're going in reverse there. That's going to be 13. Well, the square root of what is 14? Well, just plug in 14 squared. You get 196. The square root of what is 15? Well, just do 15 squared and you get 225. All right, go ahead and finish that chart. I think it's on the right side of your guided notes. Fill in underneath the radical for each one of those. So take a second to do that. I'm going to pause this while you are doing that. Okay, hopefully you filled those in here. 256, square root of 256 is 16. Square root of 289 is 17. 324, 361, and 400. I think you're pretty familiar with the ones, but on the previous page, these you might not be as familiar with, but hopefully you will be here in a day or two. All right, this is not on your guided notes, so just kind of pay attention. If you have your calculator, do follow along. Square root of 432. Okay, that is not a perfect square, and when I hit the square root of 432, I get a decimal, and I'm going to round it to the nearest hundredth. And when I do that, that gives me 20.78. Okay, now what I want you to do is just plug in these other ones and see what you get. So 2 times the square root of 108. So to do that, you just hit 2 square root of 108, and I get 20.78. All right, plug in 4 square root of 27, plug in 3 square root of 48, and plug in 12 square root of 3. 4 square root of 27, same thing, 20.78. 3 square root of 48. $20.78. And let's see if you can guess what 12 square root of 3 is. That will be 20.78. All right, here's kind of an issue. These 1, 2, 3, 4, 5 things all equal the same thing. And so theoretically, 5 different people could put down the same answer and they all represent the same thing. Well, this is one of the reasons why we simplify radicals so that everybody comes up with one answer. So if you were given this problem, the final answer should be 12 square root of 3. That is the simplified radical. Even though they all equal the same decimal, we want to come down to what we call the simplified radical. And that would be 12 radical 3. And now here what I'm going to do is show you how to take any one of these and make it into 12 radical 3. All right, now we are on your guided notes here. And this is how we simplify radicals. All right, the first one we're going to do is square root of 60. The easiest way to learn this is to do a factor tree to begin with. So you want to take 60 and you want to break it down into its prime factors. Now you can start with 2 times 30, you can start with 4 times 15, you can start with 6 times 10. It doesn't matter. We're going to end up with the same thing. So if I do start with 2 times 30, every time I have a prime number, I can't simplify that anymore, so I'm just going to circle it. 30 is 5 times 6. 5 is a prime number, and 6 is 2 times 3, and those are both prime numbers. So this is the prime factorization of 60. What I'm going to do is go over here and I'm going to write this, and I'm all going to go in order. I have two twos, I have a 3, and I have a 5. All right, so when I'm simplifying radicals, we do what's called the buddy system. You have to have two of a kind on the inside in order to simplify it. Anytime I have two of a kind inside, that means one of those numbers goes on the outside. Here's why, because 2 times 2 is 4. Square root of 4 is 2. So if I have two twos on the inside, I get 1 2 on the outside. All right, that leaves me a 3 and a 5. Anything left over, multiply back together. 2 square root of 15. That is the simplified answer for square root of 60. Kind of a double check. If I plug in square root of 60, oops. It's going to give me a decimal. And then, well, hold on here. And then I'm going to plug in 2 square root of 15, and it's got to give me the same decimal. Okay, that just kind of lets me know that I did it correctly. So you want to do a factor tree, and then you want to take out anytime there's two of a kind, you take one out. All right, let's take a look at the square root of 72. All right, let's do a factor tree on 72. 72, the easiest for the factor tree is the two closest numbers you can get together. That's going to make it a little bit quicker. So I'm going to pick 9 and 8. You could have started with 2 and 36. You could have started with 12 and 6. We'll still end up with the same answer, but I'm going to do 9 and 8. 9 is 3 times 3. 8 is 4 times 2. Well, 3, 3, and 2 are all prime numbers. They can't be simplified anymore. And 4 is 2 times 2. All right, so now I have I have all my prime numbers. It's easy if you put those in order. How many 2's do I have? I got 1, 2, 3 2's, and I got 2 3's. All right, look for pairs. I got a pair of 2's. I got a pair of 3's. All right, so the last time I only had one pair. This time I have 2 pairs. Anytime you have a pair, one of those goes on the outside. So I put 1 2 on the outside. I put another 2. Well, here's what happens. Anytime you take more than one number out, you multiply them together. And I'll do that in a second. All right, what's left goes on the inside is only a 2. And then I need to finish this by multiplying 2 times 3, which is 6. I get 6 square root of 2. That's my final answer. So to double check it, I take square root of 72. I get a decimal, and then I test 6 radical 2. I get the same decimal. All right, that doesn't guarantee you're right, but it gives you a pretty good clue that you are. Okay, so that's square root of 72. All right, third one. 2 square root of 675. This is the first one we've had with a number on the outside. Okay, I'll show you what to do with that. All right, we need to do a factor tree on 675. All right, think what goes into 675. Now, a couple of our division rules. Any number that ends in 5 is divisible by 5. So 5 has to divide into 675. Well, if I go here, let me figure out 675 divided by 5 gives me 135. Well, 135 ends in 5, so it has to be divisible by 5. So if I divide that by 5, I get 27. 27 is 3 times 9. 9 is 3 times 3. So I got 2. And underneath the square root, I have 3 3's. And then I have a pair of 5's. All right, the buddy system works here. You got to have a pair of each. You got a pair of 3's and a pair of 5's. All right, if there is a number already on the outside, anything that comes out will also multiply that number. So that 2 stays out there. A pair of 3 gives me 1 3 on the outside. A pair of 5's gives me 1 5 on the outside. And I'm left with this 3 will stay on the inside. Multiply these two together. 2 times 3 is 6. 6 times 5 is 30. So your answer is going to be 30 radical 3 for that. All right, why don't you try the next one? 3 square root of 96. Let me pause it while you do that. Okay, hopefully you got 12 radical 6. Here's square root of 96. I did 12 times 8. You could have done something different. You could have done 6 times 16, 32 times 3, 2 times 48. But when you're done, I should get 1, 2, 3, 4, 5 twos. 1, 2, 3, 4, 5 twos, and a 3. That means I got a pair of twos, an extra 2, and a 3. A pair of twos means each time I have a pair, a 2 comes out. 3 times 2 times 2 is 12, and I'm left with, multiply those back together, 6. Now, the same thing happens when you have a perfect square. We know the square root of 25 is 5, but what you can do is it's 5 times 5. You add a pair of 5s. If you have nothing left over, you have a 5 on the outside, nothing on the inside. Do not write that as a square root of 5 now. That is just a 5. Square root of 16, we know, or let me do something different. Square root of 49, we know that is 7. Don't overthink this. Just write down 7. But if you do this, 7 times 7 goes on the outside, nothing's left on the inside. Now we can also throw some variables underneath there. Okay. And this is just a little thing because we can't take the square root of a negative number. We're going to assume all variables represent non-negative or positive numbers. So that way we're not dealing with any negatives underneath the radical. And we don't have to worry about that. We're going to follow the same principle, square root of x squared. Well, you might already know that, but if you think about this, x squared is x times x. Still the buddy system. If I get 2 x's, that means 1 x goes on the outside. There's nothing left on the inside. So square root of x squared is just x. Square root of x cubed. Okay, buddy system here. X cubed means I have 3 x's. I got 1 pair. That means there's 1 x on the outside. There's going to be 1 left on the inside. So x square root of x cubed is x square root of x. Square root of x to the 4th. Well, I got 4 x's there. I got a pair of x's. Well, that becomes x times x on the outside, which is just x squared, nothing on the inside. X to the 5th. Five x's, I got 2 pairs. That gives me x squared on the outside, radical x on the inside. All right, a couple things that are rules that are gonna kind of happen. If you have an even power, you're not gonna end up with a square root. If you have an odd power, you're gonna end up with a radical x as your final answer, in your final answer. Even power, no radical x in the final answer. Odd power, you will. So for this last one we're going to look at, what about square root of x to the 6th? Well, I got 1, 2, 3, 4, 5, 6. And I have 1, 2, 3 pairs. Well, each pair is an x. I have 1, 2, 3 x's, which is x cubed. Well, hopefully you're kind of figuring out the shortcuts. Give me a second here before we do this. One, what about, say, like the square root of x to the 16th? Here's a shortcut. Basically, if you listed out 16 x's, there would be 8 pairs. All you have to do is take the exponent and divide it by 2. That tells you how many pairs there are, or that tells you what the square root is. So x to the 16th is x to the 8th. X to the 20th, you take half of 20, it would be x to the 10th. There would be 20 pairs of x's. X to the 30th, there'd be 15 pairs, it'd be x to the 15th. So anytime you have an even number inside a square root, you're going to get, you're not going to end up with a square root as part of your final answer. But what if it's odd? What if you have x to the, let's say, 11th? Okay, well, here's what's going to happen. Same idea, basically you're going to cut it in half. Well, basically just cut that down by 1. 11, think of that as cut it down to 10. And what's half of 10? That's x to the 5th. That's going to go on the outside. You're going to be on 1x left on the inside. X to the 17th. Well, 17 minus 1 is 16. Cut that in half. That's 8. You're going to be left with 1 on the inside. X to the 51st. Hold on here. Just subtract 1. 51 minus 1 is 50. Cut that in half, which is x to the 25th. And you're going to be left with 1 extra x. So if you would write out all 51 x's, you'd have 25 pairs and then 1 left over. Well, hopefully you don't have to write them out each time. You can just kind of look at this and figure out what's going on. Hold on here. So basically, if you have x to the 4th, we'll cut 4 in half. That will give you x to the squared on the outside. Y to the 8th, same idea as x to the 8th. You just make it a y. Cut it in half. It's y to the 4th. Z cubed, there's only going to be 1 pair, and then there's going to be 1 left over. So anytime there's an odd power, you have to be left with that variable on the inside. So that would be x squared, y to the 4th z, square root of z. Let's take a look at some others here to simplify it with both numbers and variables. So we can have both. We can have square root of 50, x squared, y cubed. For the constant, you still want to do the factor tree. 50 is 25 times 2. 25 is 5 times 5. And then you already have the 2 up there. So that is your prime factorization. So I go back here. I always like to put the smallest one first, 2, and then 2 5s. All right, well, you can do this. Hopefully you don't need to, but you can write out the variables. X squared means I have 2 x's. Y cubed means I have 3 y's. Got to do the buddy system. Anytime there's a pair, they go on the outside. I got a pair of 5s, so 1 5 goes out there. Pair of x's means I get 1 x. Pair of y's, 1 y. Anything left multiplies together. Well, I got a 2 left and a y left. Make it 2y. So 50x squared y cubed reduces to 5xy square root of 2y. 168 to the 4th b squared. 160. Let's do factor tree. 10 times 16. 2 times 5. 2 times 8. 8 is 4 times 2. 4 is 2 times 2. All right, now for this one, I'm going to list them all out as well. I get square root. How many 2's do I have? 1, 2, 3, 4, 5 2's. I have a 5. Should be right here. A to the 4th means I have 4 a's. And b squared means I have 2 b's. All right, buddy system. Everything that's circle goes out and then multiplies together. I got a pair of 2's, so I get a 2 on the outside. Another pair of 2's. Multiply together in the next step. I got a pair of a's, which is 1a. Another pair of a's, which is second a, then a b. Anything left multiplies together. All right, now simplify this on the outside. 2 times 2 is 4. A squared b, square root of 10. That's our final answer. Okay, so square root of 160a 4th b squared simplifies to 4a, 4a squared b square root of 10. All right, one more here. I do have a number on the outside, 504. All right, a bigger number there. And this one you're not that familiar with, but since it ends in an even number, you know that 2 has to divide into it. So if I take 504 divided by 2, I get 252. And now I have to simplify 252. Well, that is 2 times what? Let's see. 126. And then that's going to be 2 divided by, or 2 times 63. Now what's 63? That's 7 times 9. And don't forget 9 is 3 times 3. So I get 1, 2, 3 2s, 2 3s, and a 7. Don't forget about this 5 on the outside. 3 2s, 2 3s, a 7. All right, x squared is x times x, and then y is just y. Let's see what I have, how many buddies I have. Pair of 2s, pair of 3s, pair of x's. All right, anything that goes out will end up multiplying by whatever's out there. So I already have a 5 out there, times 2 times 3 times x, and whatever's left on the inside multiplies back together. 2 times 7, and then you just have that y. We'll multiply here. 5 times 2 is 10. 10 times 3 is 30. So I get 30x square root of 14y. And that'll be our final answer. All right, we're actually going to do section 11.6 in 2 parts. This is the end of the first part. Your homework will be this worksheet. You can do it on a separate sheet or you can print this out. It does not matter. Simplify completely. Simplify. So basically you're going to do the factor tree. So let me just kind of go through the square root of 40 here. That is 10 times 4, 2 times 5, 2 times 2, 3 2s, and then 1 2 goes on the outside. Multiply those back together, you get 2 square root of 10 for that one. So for this one, we end up having just 9 questions. All right, this will be due midnight tomorrow, which is Tuesday. Okay, so that is your homework, section 11.6. All right, everybody have a great day and hope to see you soon.